Hello and welcome to lesson 1-3. We're going to be looking at conditional statements and angle pairs. Now, conditional statements for you should be a bit of a review because they were covered in section U of the summer packet, but just as a reminder, a conditional statement is an if-then statement. We represent it symbolically with P arrow Q, or which would read as if P then Q, or P implies Q. And in order to evaluate whether or not a conditional statement is true, we first have to look at the hypothesis. If the hypothesis is not true, then we cannot decide anything about the conditional statement at all. Think about a treasure chest with the hypothesis as the key and the conclusion as the treasure locked inside. If you know the hypothesis to be true, that unlocks the conclusion, and then you'll be able to judge whether or not the statement is true. So for example, if I study hard, then I'll be my teacher's favorite student. Well, I don't study hard. Because I don't know about what happens if I don't study hard, I cannot draw any conclusions about this statement. It might be that I have a very charming and lovely personality. Therefore, your teacher might still like you, but who knows? So we would say that there is no possible conclusion that we can draw from this example. Conditional statements are composed of two parts, a hypothesis and a conclusion. The hypothesis is the clause after the word if, the conclusion is the clause after the word then. In the following examples of conditional statements, underline the hypothesis and circle the conclusion. So we have three examples. I'm going to do example B, and you guys get to do A and C. My hypothesis is I study for my math test. My conclusion is I will pass. Notice I did not include the words if or then when I was doing this, when I was identifying the hypothesis and the conclusion. Some conditional statements can be written in a generalized form rather than a conditional form. We're going to learn how to rewrite these sentences as conditionals. All dogs bark. That's an absolute statement. If I'm going to turn it into a conditional, I can say if an animal is a dog, then it barks. Straight angles measure 180 degrees. If an angle is a straight angle, then it measures 180 degrees. Each conditional statement has a truth value of either true or false. A conditional statement is considered true if and only if it is always true. If we can find even one example that would make the statement false, which we would call a counterexample, then we say that the conditional statement itself is completely false. So, looking at these examples, if an animal is a bird, then it can fly. Well, I can think of some birds that can't fly. For example, penguins cannot fly, but they are definitely birds. So the truth value there would be false. And my counterexample would be penguins. B, if I live in Scotland, then I live in Europe. I don't know about you, but I cannot think of a Scotland that is not in Europe. So my answer is true. We can write biconditional statements when we're able to take a conditional statement, switch the hypothesis and conclusion, and still have the same truth value. So, for example, if an angle measures 90 degrees and it is a right angle, that's a perfectly lovely conditional statement. I'm going to start off by identifying my hypothesis and my conclusion, just like we did before. Then I'm going to let P represent the hypothesis and Q the conclusion, and I'm going to represent it symbolically. So, P arrow Q would represent if an angle measures 90 degrees, then it is a right angle. And the truth value of this would be true. Now, I'm going to rewrite the conditional, switching the hypothesis and the conclusion. It's okay to make grammatical changes to make sure the sentence makes sense. So before I had if an angle measures 90 degrees and is a right angle, now I'm going to use the phrase about the right angle and put it first. If an angle is a right angle, then it measures 90 degrees. My symbolic representation would be Q arrow P. If Q, then P. We've switched the P and the Q, and the truth value is still true. Therefore, I can write a biconditional statement using this information. An angle measures 90 degrees if and only if it is a right angle. I took the original hypothesis and the original conclusion and joined them by the phrase if and only if. We could represent this symbolically using the double arrow. So P double arrow Q would represent the biconditional statement for this example. In the following examples, I want you to determine if you could write a biconditional statement from the given conditionals, and if possible, write it. if I eat pork, then I eat meat. Well, I cannot write the biconditional because if I reverse that, if I eat meat, then I eat pork, that's not always true. So the truth values don't match, so it's impossible to write the biconditional. B, 2 points, if 2 points are in the same plane, then they are collinear. I am able to write that biconditional because if I reverse it, it works. And my biconditional statement would be 2 points are in the same plane if and only if they are collinear. And C is for you guys to do. I'll check it in class tomorrow. All right, biconditionals and definitions. A good definition can be written in biconditional form. So here are some definitions to look at. Coplanar points lie in the same plane. Well, I could rewrite that as a biconditional. Points are coplanar if and only if they lie in the same plane. And my truth value would be true. A bad definition will not work as a biconditional. Snakes are animals without legs. Well, my two conditionals, if an animal is a snake, then it does not have legs. Well, that's true. But 2, if an animal does not have legs, then it is a snake. That is false because fish don't have legs, but they're still animals. So that would be a bad definition. It's impossible to write as a biconditional. All right, now we're going to switch gears a little bit and look at angle pair relationships. Our first pair of angle pair relationships would be adjacent angles. And y'all have heard the word adjacent before, and it simply means side by side. And that's exactly what adjacent angles are. They're angles that are side by side. Angles 1 and angle 4 in this diagram, 1 and 4, are adjacent because they are coplanar. That means they lie in the same plane. They have a common vertex, right here. They have exactly one common side. This line right here would be their common side. And they have no common interior points. Basically, they don't overlap. So informally, adjacent angles are side by side but don't overlap. If two angles are adjacent, we cannot say anything at all about their respective angle measures. So I go through now and list all of the pairs of adjacent angles you see in this diagram on your paper. Now let's look at vertical angles. Two angles are vertical angles if and only if their sides form intersecting lines. So in this diagram, angle 1 and angle 4 are vertical angles because if you look, this line and this line both intersect and they form the sides of these two angles. Angle 1 is formed by those two lines and angle 4 is as well. Angle 5 and angle 2 are not vertical angles because while one side of each is formed by one line, so they share this line here, they do not share the second line. So angle 5 is formed here, angle 2 here. Those are two different lines. So we would say that they're not vertical. In your notes, I want you to go through and list all of the pairs of vertical angles in the diagram to the right. Next, we have linear pairs. Angles form a linear pair if and only if the angles are adjacent and they make a straight angle. Now I'm going to go through and make a diagram of this below. Now I need to make a adjacent angles that are a straight angle. So I'm going to start by drawing a straight angle, which means basically I draw a straight line. Then I'm going to add a ray to that line to split it into two angles. I'm going to call them angle 1 and 2. Angle 1 and 2 would be a linear pair because they sit next to each other and they form a straight angle. They make a line together. Here, angle 5 and angle 1 form a linear pair in this diagram because they are adjacent and they form a straight angle. Therefore, we know that the measure of angle 5 plus the measure of angle 1 would equal 180 degrees. So angle 5 and angle 1 we would also say are supplementary. Angles 1, 2, and 3, however, are not a linear pair, mainly because they're not a pair. While they do all add up to 180 degrees, there's not just two of them, so we cannot say they're a linear pair. Go through and list the other linear pair in the diagram to the right. All right, complementary angles. Complementary angles you will have run into in middle school, and they are simply angles that add up to 90 degrees. They do not have to be adjacent to each other or share a vertex. All they have to do is add 90 degrees. So both of these examples are examples of complementary angles. Supplementary angles are very similar to complementary angles in the sense that all you have to do is be able to sum to 180 degrees to be supplementary. So here, angle 7 and angle 6, they're supplementary. They're also a linear pair because together they are adjacent and form a line. However, these two, if I look, angle UVW and angle XYZ, together they would add to 180 degrees, so they're definitely supplementary. But they are not a linear pair because they don't share a common vertex and they are not, they're not adjacent. So it's possible to be supplementary, but not a linear pair. And that's the end. If you have any questions, please email your teacher or come in for extra help. Thank you very much and have a great day.